Okay, welcome everyone. So, as you just heard, my name is Grzegorz Piwowarek, and today I will be talking to you, speaking about any alternative ways of dealing with exception handling for Java language. In my day job, I work as a system engineer for Casumo, which is a Maltese-based company. I also do trainings for Bottega IT Minds. You can find me blogging and contributing to many random open source projects. So today, we'll focus on three things. We'll start with a small rant about exception handling in Java. Then we'll revise the idea of type-driven development, and then see how we can leverage tools like optional, try either, or maybe even monad error for dealing with exceptions in Java language. As you might know already, there's been a lot of criticism around exception handling in Java and exception handling in general for quite a long time. So one of the most famous write-ups about this subject was issued by Joel Spolsky, one of the co-founders of Stack Overflow, well, in 2003. So people quite a long time ago started noticing that there's something fishy about the subject. So all those things with throwing exception, bypassing the standard control flow, catching it somewhere else, well, maybe rethrowing something else, and this would contribute to a very complicated flows to the spaghetti of your code. And if you think about this, there were more like four main points that exceptions were criticized for. So for example, the most obvious one, it would create an unexpected exit point from your methods. Well, if you are in the purely functional world, and if you try to write everything as with referential transparency in mind, there is no place for unexpected exit points. Actually, functional programmers quite often imagine their code as a set of pipes connected to each other. And, well, if you don't have classical exception handling, then it becomes quite easy, because you put one thing into a pipe, you observe the output, the other side, and if you pay attention for all the time, then you won't be surprised, because something goes in, something goes out on the other side. But if you introduce, well, if you break referential transparency and introduce exception handling to that, suddenly those pipes start leaking in unexpected places. If you don't try catch everything all around. So the other thing is, once you throw an exception, then naturally you need to catch it. Sometimes you might catch only like some subset of type hierarchy of a particular exception. So the exception might be propagated further, and then, well, it behaves out of go-tos. So if you have those try catches, well, you try in one spot, you jump abruptly to another, then you handle it. Well, there might be another exception thrown over there, and then you keep jumping all around. So also some people were sarcastically saying that exception handling in Java, especially checked exceptions like enterprise-grade go-tos. Well, other than that, all those complicated control flow paths are invisible in the source code. So that's problematic. And if you start going async and exceptions start getting thrown in different threads, it's quite easy to lose them. And what's quite interesting is that exceptions don't come for free. So if you imagine an object, like object-oriented in object-oriented world, an exception, well, you might think it's a POJO, having a cause and maybe some message or something else. But it turns out that if you try to instantiate an exception in Java, well, it's much more costly than instantiating any other POJO. Do you have any idea what this might be? I don't hear anything, but stack traces, yeah, exactly. So the important thing about exception when you create them, well, you need to collect a stack trace. Well, this all big ugly thing that pops up in your logs. And it's very costly, because you need to freeze everything and start and go through the whole stack by collect frames and construct it. And it might be much more expensive than you might think, at least relatively. If you actually want to read in depth how much it costs, there is a very cool write-up about this by Heinz Kabutz. But let's focus on one particular benchmark from Norman Meurer from Nettie. So Nettie is a high-performance networking for Java, and they needed really to push the boundaries further in terms of performance. So at some point, they started benchmarking and seeing how that would affect the performance of the library. So they did the experiment. They made three simple cases. So one case involved simply creation of an exception and throwing it on the spot. The second one, they would just take an exception in one particular context, cache it, and then keep rethrowing it. Because if you throw the same exception in one particular context, you can reuse the same instance. Why not? And the third, the most drastic optimization, involved actually creating a static instance of an exception and stackless. And the difference was huge. So if you look at the graph, there are three sets of results here. And results are presented in operations per millisecond. So if you look on the right, you see that in the case where you had a static and stackless exception, we would get at least around 60 operations per millisecond. But on the left, you might think it's some kind of error with the graph. But no, there are actually those bars, but they are super low. So as you can see, the difference is huge. On the right side, with stackless and without playing with stack traces, we got 60 operations per millisecond. But on the other hand, using the standard approach, we get way low than 1 per millisecond. Actually, it might look very scary, but you don't need to be troubled with that lot, because if you throw that many exceptions that they cause your application, the performance to degrade, then probably you have different, bigger problems. Other than this, JVM actually is caching some exceptions, so don't worry about this that much. But it's quite important to be aware of that. So this is how we went in Java. But other languages, they took their own way. One of my favorite approaches is in Go. Well, it's not that nice as you might think, but it has some good points. So what Go did is they introduced the possibility of having more than one return value from each method. So imagine that you stop throwing exceptions at all, but you have a separate error value that gets returned additionally to the main value, the main return value. And this can be quite cool, because suddenly, if you just keep observing those values, nothing will leak undetected. That's quite cool. And then the simple error handling looks like this. So I know you might be a bit disappointed, because I told you that my favorite exception handling is pretty much involving just a simple null check. But let's actually try to appreciate that for a second, how easy this is. By introducing a clear distinction between errors and exceptions, that got simplified a lot. So we got two values that got returned. If something happened, it's not null. You check for that and move on, and that's all. So there's no control path being disrupted or anything, just a simple value being returned. Exception is a value, error is a value, and not some special being that causes, distorts your control flow. But actually, works really great if you just want to emit an error, return an error. But there are situations where you don't want your users of your APIs or whatever, you don't want them to recover from that. And yet, there is a second separate mechanism for that. In Go, you can panic. But if you panic, you end up in a place where you don't expect your users to recover from that. So it was possible by introducing a clear distinction between those two. And that's pretty cool. Well, actually, you can recover from that using deferred methods, but that's a completely another story. But meanwhile, what's happening in Java? In Java, it turns out we start identifying so many possible bad practices related to exception handling. And now it's not the point to just go through all of them and start bashing Java. But it's important to realize that actually there are so many bad practices, anti-patterns identified so far. Of course, obviously, they are contextual. So we are today on the pretty much JVM conference. So I hope I don't need to advocate too much the static typing, but let's actually try. So recently, there's been a lot of discussion. I mean, it turns out like the history tries to repeat itself. So we go from dynamic to static, and after going to static typing, we kind of miss the opportunity to go as fast as we could in the dynamically typed languages. And this actually sparked a lot of discussion. So for example, Uncle Bob wrote a blog post a few months ago bashing Swift and Kotlin for being too statically typed. Because in the ideal world, we would all be mature, we would use all our tools as mature people, and just write tests. So we would enforce all that stuff that types would give us, not by using types, by writing appropriate tests that would secure us from all those stupid mistakes that we would make, by assigning, for example, a string to a tree object, whatever. But it turns out that it's not very convenient, because suddenly, well, how many tests would you need to write to do that? And another question is, how long does it take for your tests to run? Because often, if you get distracted if you are in the flow and you get distracted for more than like 10 or 15 seconds, you lose the flow. And it's very hard to come back to that state. So that's not perfect. And at this point, I think it's quite important to recall the main principle of the Agile. What's the main principle of Agile? The ability to receive feedback fast and adapt. So we are no longer, going to a client, asking for some guidelines, then developing for 2 or 3 years, only to, get back to him or her and show the product, and then it turns out it's nothing like it was supposed to be. So by introducing a short feedback cycles, we can quickly adapt to everything that's changing. We can very quickly spot the problems. We don't need to run our tests or discover our errors at runtime, because this is what's happening at compile time. And actually, what's happening if you properly reuse type-driven development is that you actually get those tests, and they are run constantly. Okay, if you do something, a stupid mistake in your IDE, everything ends up being read pretty quickly. But it requires a little bit of an effort to actually be able to get to that point. But at the end of the day, right, you can go faster, because with dynamically typed languages, you don't get compile time errors, right? So if you want to leverage the power of dynamically typed languages, it's quite easy, because, you don't write types, and then you benefit from that, because you can move on faster, right? This is not the case if you try to do those ideas in statically typed languages, because it turned out that, you need to invest in that. And we often don't want to do that. So actually we end up with stringly typed language and not strongly typed. But if you want to leverage the power of that, the idea is to actually try to shape your domain and invest in building proper types. So this is how this would look like if we invested into that. We are building a type-safe stronghold that will protect us from all those stupid mistakes. So as you can see, obviously, name, surname, address, those are all strings, right? But not every name is a surname. Not every address is a name, right? So by constructing separate types you can protect you from that. You can add additional checks and prevent yourself from assigning, phone numbers to surnames and so on. And we actually did that in one of our Kotlin projects, and it saved us so many times. So, for example, for every long type stored in a database, we created our own wrapper. And, well, it was inconvenient at the beginning, okay, because, well, who would ever, assign a car ID to a person ID or something? So at some point, we stopped doing that. And this is when we actually noticed that those kind of stupid mistakes stopped appearing. So we quickly rewrote that to actually accommodate those ideas. And it turns out that in Java world recently, we started noticing that we can do things with types. So in Java 8, we got tools like optional or stream or completable future, which were great at that, because they would just take and encapsulate our values in some computational context, and they would abstract out some things that would need to normally worry about. So with optionals, naturally, if we represented our types as optional, well, naturally, we signalize very explicitly that those types can be or can not be there. And this is cool, because when someone receives it, they need to actually handle that, and there is no way, you can't run away from that. So if we can do this, for example, with optionality, why not kind of go further and use the same approach when dealing with exception handling? And it turns out other languages have been doing that for quite a long time. So a short disclaimer, those ideas that I'm trying to show today, well, they can be found in many different languages. You can find them in Haskell, Scala, Kotlin, and many other languages in many different libraries. But today, I will focus on Waiver because it's as close as it gets to Scala, well, and should be quite easy to adapt. But there are other solutions. You should be aware of that. So we won't be digging quite a lot into a particular implementation. I'll be showing you some ideas, but it's up to you to go and read the docs, actually. So the first idea is a try object. So if we can put an object, into an optional and represent an object that, well, can be optional, why not do the same with exception handling? Okay, but how do you put an object into another object, and that object can throw exception? Doesn't make sense. Well, we are in the functional world. Functions are objects as well. So it turns out that now, in order to encapsulate something in our custom type for exception handling, we would need to take a function and put it inside there. And how does it look like from the consumer side? So for example, imagine a simple method like get search results that would throw an IO exception in the past. So let's try to rewrite that. And that's as easy as it is. So basically, the return type becomes wrapped into our custom object that can handle exceptions and give us a very easy API for interacting with this one. Well, that's all. And now, if you are a consumer, you receive such an object, it turns out that you would work with that in a very similar way as you do with, for example, Stream API or optionals known from Java. Let's actually have a look. I hope you can see everything. So let's imagine a very simple, well, case scenario. What's a class that throws a lot of exceptions quite often? Well, creation of URIs. I guess you can see spoilers in my imports. Let's try to do that. So again, if you would work with optional, you'd put some normal object inside. But since we are passing actions around, we need to do a simple lambda. So let's try to create something here. Let's say. And that's all. We already encapsulated our value in a try object, and as you can see, that the API is very similar to what you would get if you worked with an optional. So you can declaratively pass some methods to it, and as you can see, you don't need to worry about exception handling at this point. Okay? This is declarative programming. It means that, well, our value is encapsulated in this exception handling context. So at this point, we don't worry. We have a very nice API for doing that. If it turns out that the exception was thrown underneath, well, nothing will happen in this function that we pass to a map call. But if something goes, if we land on a happy path, everything gets executed. So we can, for example, use a filter. It won't be very complicated right now. But what's cool is that actually you can see that those solutions in many different languages, they will have a lot of very domain-specific methods for spicing up, for making the whole thing much easier. So, for example, in Waiver, you can find methods like recover. So let's say that somewhere along the way, you encounter a null pointer exception. And in case of the null pointer exception, default to a string. So this is how, for example, you could jump back onto the happy path. And then, for example, get the value or specify another default one. So this is as easy as it gets. If you would be working with optional, that's very similar. So, for example, you go for a map call, you go for filter. So the huge benefit of all of that is that actually, if you learn one tool, you will immediately, if you start to understand that, you'll be able to apply that in many different tools from other languages, because there are much more than that. So if you browse the API, you will see many, many different methods, but those most important ones that you need to be aware of is pretty much map, filter, and flat map. Those you will find everywhere and in many different languages. Sometimes they might be called different, but at the end of the day, this is the basic functionality. Other than that, there will be many multiple different custom methods. And now, let's actually have a look how that could look like from the producer side. So let's say that we want to implement the method getSearchResults, and we want to kind of use two internal methods for that. Let's use getFromGoogle and getFromDuckDuckGo. So as you can see, if you look at those signatures, they are quite a little bit different. The one just throws no such element exception and IO exception, and the second one throws just an IO exception. And now, if you try to compose them, you can see that if those tools are designed in a proper way, it's quite easy. Well, it might look quite complicated, but after playing with declarative programming for a while, it ends up being very easy, very intuitive to work with. So, as you can see in the first line, just like in the example I showed you a few seconds ago, we put the lambda with a simple call, with getFromGoogle call, straight to a try object. And then, well, as we can see from the method signature, it throws no such element exception and IO exception. Well, what does it mean that there's no such element exception? That means that there were no values found, right? So we recover from that by simply returning an empty list. Well, and then turns out we go start inspecting the code, and it throws NSA forbidden exception. Well, but at the end of the day, it's also an empty list. So we recover from that. And in the last call, we fall back to getFromDuckDuckGo, and so on, and so on. One very important thing to remember about is that sometimes if you work with multiple tools that actually work this way, they return those monadic types, you will also often end up in situations where types are actually nested. So you might end up with option from option, tries from tries. And since this is not, we are not talking here about monads and stuff, but it's very important to remember that when something gets nested, well, you might think it's, well, super safe, right? Because if you return a try, some object that gives you some safety regarding exception handling, and you put try into a try, it might be super safe, right? But it's not. It's just very complicated to unpack. Then at the end of the day, to keep unpacking it as those Russian matryoshkas. So if you ever encounter something like this, it's very important to remember that you have special methods for dealing with that. So whenever some stuff starts getting nested, you need to remember that there is a flat map for that. Other than that, in functional languages, those tools are modeled in such a way that often those can be leveraged in pattern matching. Unfortunately, in Java, we can't do this. We can do this in Waiver, but it's not the most beautiful implementation I've ever seen. Well, it's great that it works, okay, but it's not very practical. But the great thing about this is that it won't be really needed soon, because we have JEP 305, and pattern matching will be getting soon to Java. Well, not in 11, not in 12 probably, but in some near future. So, let's go to another tool. Let's focus this time on option. Well, you might be thinking that option is designed for optionality and not for exception handling. But actually, there is a very good point here in how you would use that. So, for example, let's imagine that we have those two methods, like find one or value of. They usually would throw no such element exception, or maybe a number format exception that's not very informative. And, well, we already know that we can use try for that. So let's try doing that. OK, it's better a bit, quite easier. Users of your consumers of your API can now have a choice. They can, at the end of the day, well, decide to throw exceptions. But still, okay, if you have an method called find one that would throw no such element exception, and you rewrite that to try, well, it doesn't give you that much value, okay? Because try is very cool if you want to actually process the exception in such way. But here, there's nothing to process. There's an exception that gives you an information that there's no object. So maybe why bother involving this kind of functionality here? Well, in many cases, it turned out that it's the most easy way to go would be to simply use options for this way. We can simply abandon exception handling and remember that if we are dealing with optionality, we have an option for that. If you throw an exception, it's especially a checked one. It forces your consumers of your API to handle it in a special way. With those tools, it's up to the consumer what to do with that. And if you actually start doing very naive searches on GitHub, you will see that this kind of code gets abused a lot. So we could actually be those that stop those numbers from growing. So another idea. So as I told you at the beginning, I like the approach that Go used. Well, we could do that in Java, okay? We can't return more than one value. I mean, we can return only one type from each method. But why not simulate this? We could use tuples. We could put two values there, okay? And then, well, we can manually just do null checks and check. But it starts looking very ugly, because tuples were not designed for working with optional values, with nullable types. And so this generally contributes, if you try to do it this way, it contributes to like this omnipresent Java mutable null check feel. That's not very cool. So actually, let's try to do better. And it turns out that many functional languages, they have something like that designed for those use cases. Those would be eithers from Scala, for example. And this either is a very general purpose tool. It actually doesn't have anything to do with exception. It's just a tool that can hold one of two types, but only one. Not zero, not two, always one. And this is very convenient, because now we don't need to actually involve exceptions. We can write our custom error objects and return them from methods. And the API is designed in such a way that it's very easy to deal with juggle between those two values. And if you actually try to thinking about that, is that we already covered try. Try can have inside either a successful value or an throwable, or an exception, right? So if you don't get the concept of an either, I think it will be easier to understand if you think about try as a very special case of an either. So either that can hold either your result type or an exception is very close to simple try. Also, it's very important to remember that if you deal with, for example, optionals, they are biased. Okay, they promote existence in this case. So, for example, if you put something into an optional, if you call a map method, it will actually get the function passed to it will get called only if something is inside. It will get totally ignored if the optional is empty. Same, for example, with tries. Okay, it's biased towards having to the happy path. So if there was an exception, the method of like map and filter won't get called at all. But with either, it's different because it's a very general purpose. So you can have one of those two values, but there is no bias. It can be no bias in most cases. So there needs to be a way somehow to specify which side we are working on, and we'll get to that soon. But actually, one of the common trends now is that eithers become right biased. So don't be surprised if you see in some languages that either by default is right biased. So, unfortunately, if you deal with try and so on, you will find many cool methods for dealing with exceptions. That won't be the case with either, because again, it's very primitive. It holds just two values, and you can use that for exception handling. So whenever you want to instantiate those objects, well, it's super easy. You have static factory methods. So you either create a left one or either create a right either. And now, again, if you go through the API, you will see many different familiar methods, but the most important ones to remember about are those two at the top. So whenever you want to work with left of or the right side of either, you need to use projections. And by using a projection, you can specify which side you want to work on. So left projection for an either is a left biased either. Right projection for an either is a right biased one. So for example, if you create a left projection, you pass something to a map method, and it turns out the either was left, then it gets executed. But if it was right one, nothing happens. And the other way around. If you have a right projection and underneath is the right one, and you call a map filter, something happens. But if it's the left one, nothing happens. Obviously, you will see many different methods, even on unbiased ones, but usually they will be very cumbersome to work with. Because you would need to always pass methods for two cases. So remember about projections, it makes things easier. So let's actually try to have a look at some example. So in order to properly work with eithers, we would need to create our own fetch errors, error objects. In this case, for example, we might want to store only strings and string message and HTTP response. And as you can see, it's very cool because it's just one line in Scala. Unfortunately, if you go to Java, well, you need to add a bit more. Constructors, getters, setters, equals, hash code, and so on. So this might be discouraging a bit, especially given the fact that it's like 44 Scala case classes in one, squeezed together. But the good thing is that this will be soon coming to Java. Not in 11, not in 12, but in some future. So let's have a look at the example. We now have our own custom error object. We can use it. So let's have a look at the previous example, the one with try. So now let's rewrite that. So we get rid of the try, and instead of this, we package our result type in an either fetch error or our desired type. Let's see how it looks like in practice. So now, you, as a consumer, you call a method, get search results, and get an either. But now, if you want to work with a result or an exception, you need to make projections. So let's say that we first handle the happy path, we go for the right projection, then we do something with that, whatever we want. And then we move on to the left side, which allows you to handle the exception part. So in this case, you probably want to extract a message and let's say and log it. So this is as easy as it is when you actually get to understand the idea of projections. What's actually quite cool is that either is designed, well, can be used not only for exception handling. So for example, and whenever you need to deal with like business logic that diverges into two different paths, you could use either for that. So for example, imagine some internal methods of DNS resolvers or whatever. Okay, if you try to resolve a domain, you just you send a request to a DNS, and well, you either get you find everything, or you just want to forward further to another one to get the remaining part of the domain. Well, that could be modeled with either as well. But if you go and jump into Scala sources, you will see that there are some crazy usages of that as well. So, for example, if you look at the tailrack in Scala, you'll be able to see that it's also implemented using either. So, of course, it's with pattern matching, but as you can see, it has some real-life applications. Well, at least if you are writing functional languages. So, a few important questions now. Let's say that you would like to try to use that in your daily projects. So, what can we do? We actually tried to use eiders in 2014 when Java 8 was out. We needed to write it by ourselves. But since quite a few years passed since that time, libraries are, well, there are libraries on GitHub that can help us with that. So my favorite will be Waver. If you want to go for that, it's as close as it gets to Scala as possible. So if you try working with that, if you worked with Scala, it should be quite easy to catch up. But the most important part, the most interesting one you could do is to actually try to take part in the JCP, which is a Java community process. Because you mightn't know, but features in Java kind of get through some community, open community process. And this is actually what happened with Lambda expressions or Yoda time, that you might know as Java time right now. So a few years ago, Mark Reinhold would say that Java will never get Lambda expressions. But it turns out that Project Lambda was pushed and we are there. Then people were complaining about the date API of Java. Well, community pushed it, and now there's Java time. And so on and so on. So if you'd really like to see those kind of tools in Java, well, you can actually do something about that. So we are getting slowly till the end. Let's try to recap what we've seen today. So there was a little bit of rant about exception handling in Java, but exceptions are actually not that bad, okay? It's important to see, well, the bad sides of that. But it's very hard to, often we are not working in isolation. We are using external tools and so on. So it's not that easy to absolutely cut off from that. Well, they are part of Java. Okay, many methods just throw them. You can't ignore them at all. But if you actually use exceptions responsibly, if you use them as in situations where you actually want to signalize really exceptional situations, they were quite fine. So don't worry to that. Don't run home and don't convince your friends in your team to rewrite everything to eiders. They might hate you for that. So the main thing is that if you really want to implement those ideas, probably try is the most practical way to start now. Since try is not really a concept from a functional world. It's a kind of a glue that allows you to encapsulate exception handling and expose functional-like API for that. And this is very easy to use. You can just add it to every project and just work with that. If you really wanted to go for eiders, that would be very difficult, because suddenly you would need to try to expose facades for your APIs, encapsulate different things, and then return eiders, which is not perfect, not very practical. But try, you can add to your project basically anytime. Another thing is, it could be quite important to think if you really need exceptions. There are many cases where exceptions can be avoided, where you, for example, don't need no such element exceptions anymore, but you can go for options instead. So that's also sometimes exception handling, well, can be handled by avoiding introducing exceptions at all. And if you really need, if you need to go for some advanced use cases, you can go for either. That will help you not only with exception handling, but with every case where you are dealing with business logic that diverges at some point. Another thing is, it's a good idea to remember about the waiver library that becomes a new Guava. Guava, I don't remember adding it to projects for some time, but now waiver is one of the first things that I add to projects, well, if it makes sense. So let's remember about that. But the most important thing to remember from today is that actually using common sense is the ultimate best practice. Because if you go crazy with all those monadic types, you might end up with incomprehensible stuff like this. So don't go crazy. Thank you very much.